Sure. So last time we did iteration abstraction, and we left with a lecture lab, which you should have looked at over the weekend. So what we'll do today is actually go through and finish that lab, and then also dive into kind of more advanced iterator usage. So far we've been reusing iterators that exist within the Java collections. And so what we'll do is actually build one ourselves from scratch. A couple of things to remember. The project is due tonight. Project is due tonight at 11:59 p.m. You should commit it to whatever your master repository is, whatever you've decided. We talked about demos last time. So demos are going to be in lab and also in lecture. If you're demoing in lecture, you should have gotten an email. If you don't have a time slot during which you're demoing, you should send me an email right now, as soon as possible, because we need to get your slot. So the schedule for Wednesday and Friday is that the people who are doing demos will show up. No one else has to come. There's going to be leftover time on Friday. So if you want, I'm going to be here the entire time. So if you want to come and actually review for the final during that time, you're welcome to come and ask me questions. And then, of course, the final exam is on Friday, December 6th, in the morning. It moved to CIRS 1250. We still are not going to have computers on the exam. So plan accordingly for not having computers that you can use. Any questions about the project demos or what we expect of you from within the demos? Everybody has their script together for the demo? Yeah? Yeah, work on that. Okay, so today we're back to the iteration abstraction. And so the one thing I should mention is that there's going to be a bunch more stuff happening during next week. We're going to have review sessions. And there's going to be extra DLC hours and etc. There's going to be a bunch of stuff going on. So you should always look at the schedule for up-to-date information. So, Piazza is going to go offline at some point. We're going to have QA sessions. We don't know the rooms yet, so to be confirmed. So check back on this page for more details. And then just one other notice that for the final, we're going to have some final practice questions for you. They'll come from prior finals that were given for this class, but we're not calling them practice. I'm not calling it a practice final because the questions on our final will differ in a few ways. So look at this page for more info. So getting back to iterators. So this was the picture that we were looking at last time. This is what we put together. And this is essentially the best way you can draw the iterator pattern. There's not like one neat UML class diagram that you can use to express it. So all visualizations of it sort of fall flat. So in an iterator pattern, what you have is you have an iterator and you have an iterable. And those are two high-level interfaces that Java provides to you. And so an iterator iterates through something, like a collection, like a list or a set, and it needs to provide three methods: has next, next, and remove. And then on the iterable side, whatever class implements this interface needs to provide the iterator method. So you have, a Java collection, for example, implements this interface, and then this interface is then, implemented and extended in different ways down below for actual concrete data types that you're used to. And then for each of these data types, there's a specific iterator that will iterate through the list or the set. So this is like nice and simple, nice and neat. So let's look at the lecture lab, which had to do with the remote control. Would help if I had internet. So for the remote control, you were basically told that, there's a remote control app, and in my app, I'd like to iterate through channels in my remote control. So I want to write code like this, where I have an iterator through RC. RC is a remote control. And the classes that I have is I have a remote control, which I have to add code to, and then I have a channel. And a remote control contains some number of channels. Right? So basically the lecture lab is about filling in the details of those two classes. So let's do that. So for the idea that what you want to keep in mind while you work on this is that you want something very similar to this diagram in the context of channels and remote control. Right, so what we're going to have is a class called the remote control. And we want remote control to be iterable. So we'll have it implement the interface iterable. And remote control, so now whenever you have iterable interface, you have to think about what are you going to be iterating through? And in the context of a remote control, it's going to be channels. So there's going to be the channel class. And the remote control is going to know about some channels. So there's going to be some relationship here. And probably it's associative, and probably it knows about some number of channels. Right? Remote control with a single channel doesn't make sense. So this iterable interface will allow us to iterate through the channels in the remote control. Right? This is what we're building. So now in code, since my remote control needs to know about channels, the first step is to actually say, well, I need a container for channels. So for that, I can use a set or a list, and you can choose whatever you want. So I'll just say I have a set of channels. I have to import my set. Now that I have this set, I need to probably initialize it. Right? So I need to say channels equals new hash set channel. Import hash set. Now at this point, I have remote control that knows about channels, and I can add channels. So I can say channels.add new channel, and channel takes the number as the argument in the constructor. So now I have this little remote control to which I can add channels, right? Now if I want to iterate through my remote control, one alternative is to expose channels, right? Let people iterate through channels. But the whole idea with the iterator and iterable pattern is that you want to actually have remote control implement iterable. And it's going to implement it as a version that iterates through channels. So now I don't have to reveal the details of my internal implementation. Right? I just return some iterator that a client of this class will use. So for remote control, I need to add this iterator method here, down below. And I'll just simply return the iterator that channels already has. So channels is a set. Sets in the Java collection already implement iterable. So I'm going to reuse the iterator that channels have. Okay, so by doing this, this allows me to write code in my application that looks like this. Right, so now if I run this thing, it'll work. I'll print out all the channels that I have. Any questions about this kind of simple example so far? So it's simple because in this case, channels, this set, actually provides an iterator. So I don't have to build one from scratch. I can just reuse it because I know that channels has it, so I can return channels.iterator. Okay. The more advanced usage for this is the array list. So if you open up the array list package within the same project, you'll notice that there's an array set class. And the array set class is slightly more involved, more complex. The array set class basically attempts to build a set using an internal array. It's an example, right? Obviously, Java has a set built into it, so you would just use that. But let's say you wanted to build your own because you want it to be more optimized in some way. So then you would have this array set class, and internally it maintains some set of objects. And the set of objects is an array. And the reason it's objects is because you want it to be as abstract as possible. So you want this array set to be parameterized with E, and this E could be any type. Right? So if you wanted to create a set of integers, you would say, well, I'm just going to say array set integer set equals new array set integer. Right, so I can write code like this, which will make my code really generic. Right, so by creating this array set that deals with objects, whatever they may be, I can create a set that's an integer. I can also use the same code to create a set of strings. And my code would look very similar. So that's what this E argument allows us to do. Now, the other thing I want to do is to be able to iterate through these things. Right, so I want to be able to write code like for integer I set. And then down below, I'll actually use this I in some way. And in general, for the iterator pattern, right, you're trying to support a use case where you're iterating through some type variable. And the thing after the colon is some instance that implements iterable. Right, so this is the general case. And this is, specific to array set. Okay, so this is the pattern that you want to support. We have this array set data structure. So now it's a matter of making sure that it actually implements iterable correctly. Now, what does it do internally? Well, it maintains an array, and it knows about the number of items it contains. And it has some capacity. And initially, when you create an array set, you're just going to create an array of a specific size. And you're going to say, well, it has no items. And then if you want to add an item, well, remember, it represents a set. So internally, you have to actually check whether the set contains the item. So first, check if this new item is null. Don't allow people to add null items. But then check if the set is null. And if it's not null, then we're going to do one of two things. Either the array is full, in which case we need to expand it, or it's not full, in which case we can just assign this new item to the last kind of position within the array, last available position. And if it contains this item, return false, because we've already added it to the set. So we have this abstraction. We're exposing an interface, which looks like this. It's a set, and you can add an item, remove an item, check if the set contains an item. Just the really basic, straightforward set interface. But we're implementing it using an array internally. So this is add. There's also contains, which, as you'd imagine, just iterates through your array and then checks if any of the items are actually equal to the thing you're checking containment on. So this is like the very straightforward implementation of set using arrays. Now if I want to make sure that this implements iterable, I'm going to add this iterator method, right? And this iterator method at the very bottom needs to return an iterator for items in my set. But now I don't have a data structure that has an iterator built into it. Right? My data structure here is my internal one, is an array of objects. An array of objects doesn't have an iterator. So if I want to return an iterator, I need to build one. I need to create a new class that's going to implement the iterator interface. Right, so the iterator interface needs to have these methods, has next, next, remove. And so it's iterator E, which iterates through something that returns objects of type E. So now in my code, in this iterator, I need to return an instance of that. Okay, so what I'll do is I'll say, I'll return new array set iterator. And now I have to actually create this class. Now there's kind of a design choice, right? I could create this class as a new separate file within my project. But now that you know about private classes, it actually makes much more sense to declare this as a private class within this class. Right? And the reason for that, the reason you want a private inner class, is because array set iterator should only be visible to the external world as an iterator. No one should really see this class. Which is why I'm going to create a private class, array set iterator, down below. And so I'll return an instance of it within my iterator method. Right, so now I have this private class of set iterator. It's going to implement iterator E, whatever E is within the outer class. And because it implements this interface, I need to implement the 3 methods that every iterator must support. All right, so now I'm building my iterator from scratch. I'm defining it for this data structure that contains an internal array that has no iterator. So I need to figure out how to do that. Right, so this is the case, this is the more advanced use case for iterators, where you need to build one from scratch. And here is where you get to make a bunch of decisions, like how do you iterate? You know, what item should you return? How do you determine if you have a next item? You have to answer all of these hard questions that, you know, the Java library developers have already done for you, for the existing iterators. So I'll start off by saying, well, I'm creating an instance of it, so I need a constructor. Right? So I'll create a constructor for array set iterator. And notice that I passed an argument to this constructor here. I passed this, which is my array set. And the reason I passed it in is because the iterator needs to maintain state. It needs to know about where it is within the iteration. And furthermore, it needs to iterate through this set, so it better know it, better have it, access to this instance. So I'll just set to be this passed in argument. And now I need some kind of location, you know, my pointer to which item I'm actually iterating through within my set. So I'll just say car location and set car location to be 0. So one way to visualize what I'm doing here is that we have this data structure, which is an array set. An array set internally maintains an array. And so this array looks like something that, you know, just has a bunch of slots, some default number. And then every time you add something to the set, it gets put into one of these slots. right? So I might add 2, then I might add 5, 6, 7, so forth. And so every time I add an item, this pointer moves and keeps track of where's the next free position. And when I fill up this set, it's going to expand it. So once I filled up this set, it's going to double its size. Now I have twice as many items, and I'm just going to copy them over. So that's what my array set does. If I want to iterate through this data structure, I have a couple of options, right? Because no one says how the iterator needs to behave. And it's a set, so there's no particular order in which I need to actually iterate through a set. So I could iterate, for example, from starting at the end and moving towards the front. That's a totally legitimate way for me to iterate through a set, because there's no expectation of order. Right? I could also iterate by just randomly jumping across items in whatever order I choose. Right? So, and of course, this really trivial way is to iterate from the front. So just start at location 0. So this is my current location pointer. And I'll say, well, right now you're at 0. And so if I call next on my iterator, it will return the number 2. And then current location will be updated to be 1, and this pointer will now point at the next position. Right, so every time I call next, my pointer moves, and I return the item that the pointer is pointing at. So that gives us a hint for what to actually fill into these methods, right? Has next, next, and remove. So that's how next will work. And then has next needs to determine, well, am I at the last position? Right? Is it possible to move this pointer? So if my pointer is pointing at 10, has next should return false, because there's nothing after 10. There's no more items to iterate through. Okay, and then remove, of course, needs to remove the current item. But at least in today, we're not going to implement remove. Okay, so let's try to do this. So my current location is 0. So if I'm calling has next, if I were to replace this, I actually want something that tells me whether more items remain within my array. And I have current location, which tells me where I am, and I have the set. And so a set has some set of items. Particularly, it has a method which tells me how many items it has. The size method. Right, so size tells me the number of items in my set. So if I want to check whether I have any more remaining, I just say, well, is my current location less than set.size? And when I evaluate this expression, it evaluates to true or false. It's going to be true if I have more things that I can return. It's going to evaluate to false if I reach the end of my array, if I'm pointing at the last item. So that's my implementation for has next. Now to implement next, I have to do a little bit more work because I actually have to return an item from my set. So first step in next is that I actually have to check that I have items remaining. Right? So the first step is to say, well, if not has next, and I probably want to throw some kind of exception here. Because it's a problem, right? And what exception exactly? Well, this is the iterator. This implements iterator. So my iterator help page should tell me which exception I need to throw. So here it is. It throws no such element exception if the iteration has no more elements. Right? So I'm going to abide by this protocol. I'll say, well, it throws a new no such element exception. So that's part of my next method, is this check to make sure that I have something. the next thing is going to actually be extracting the item from my set. So I know the current location, so I can say set.items, and I can retrieve the item at current location. So maybe I'll assign it to a new instance of item. And this thing is not going to compile because, to start with, I need to cast an object to E. So remember, my items array within my array set is an array of objects. But the return of this iterator must be an E. So this is where I would use a cast. Right? And I know that this is safe usage of the casting because I know that this iterator E, this E, is the same thing that is exactly the E that is up here. So even though I contain objects, I know that actually all of these objects are of type E. Okay, so this is first thing that I do. The next thing that I do is that I have to move the pointer. So cur location points at the thing I'm going to return right now, but then the next time that I call next, it needs to point to the next thing. So for that, I need to increment cur location. We'll just do that like this. And now that I've done that, I'm ready to return this item. So this is just return item. So this is a very minimal iterator, right? It has next, it has a next, and really each of these is just a couple of lines long. For more complex data structures, you'd actually build iterators that are more advanced because you may desire some specific kind of iteration from your data structure. And for this final method, remove, well, maybe right now we don't want to remove anything. So there's another, there's a special exception, the unsupported operation exception, that you can throw if you don't want to implement remove. That's kind of nice, right? You just say, well, not today. Maybe somebody else will do that. Maybe my partner will do that. So this is the complete iterator for my array list. And then to see it in action, so here's a little program. So if I have an iterator, then I can use it like so within this kind of pretty syntax where I use a for loop. And so I create an array list of integers, I add a few numbers to it, and then I iterate through them and print them out. But of course, now that I have this iterator, I can have the more advanced usage, which is more verbose, but is equivalent to this for loop, where I'm going to manually actually request each item from the iterator one at a time. So if I run this code is going to behave identically, right? I'll get exactly the same printout. So any questions so far about this iterator pattern? So it's a private class, right? I defined it as a private class inside a array set because I need a class. It doesn't have to be a private class. You could define it in a separate file, as you're used to. And then this thing needs to implement this interface. And I'll create a new instance of it and return it from the iterator method within my array set. And that completes the pattern, right? I have my iterable, which is my array set, and I have my iterator, which is my array set iterator. So now that I have those two, I'm done. Now I can iterate through my array set. So if you want to practice this a little bit more, it's actually, so the same project has a package called multi-recommender. And the multi-recommender has an app. It's basically like a course recommender. And within this app, it tries to iterate through courses that a recommender contains. So it's kind of like very similar concept, right? You just want to make sure that you can write this kind of for loop. But to write this kind of for loop, you need to make your recommender implement iterable. Right, so this is really good practice for the final, where you would go and take this code and you say, well, I want to add the iterator design pattern to my code, to my existing code. How would I do that? Right, how would I change this code to make sure that I can iterate through courses with my course recommender? And it's a little trickier because here you have a map of recommendations. So the iterator that you'll return needs to reason about maps or somehow deal with them. Right, which is trickier than sets because sets have this really straightforward iterator. This will be a little trickier. Great. So really, this is all we have to cover within the course. I think we're done, you guys.